Now that we've calculated all the sums of squares necessary for the factorial analysis of variance, we can proceed to actually carry out the f-tests. Here we'll put degrees of freedom. Here we'll put the mean squares. Here will be the f-test, and here will be the probability of the f's. We're actually going to calculate 3 different f-tests, one for hospitals, one for sex, one for hospitals by sex, and the error in every case will be the within cells mean square. So the first thing we'll need is degrees of freedom. There are 4 hospitals as shown here. So there will be 4 minus 1 degrees of freedom for hospitals. There are 2 sexes, male and female, so there are 2 minus 1 degrees of freedom for sex. And for hospitals times sex, the degrees of freedom will be the degrees of freedom for hospitals times the degrees of freedom for sex. So this will be equal to 4 minus 1 for hospitals times 2 minus 1 for sex, and there will be 3 degrees of freedom in the interaction. Before going to the degrees of freedom for the sums of squares within cells, let's look at the total degrees of freedom. The total degrees of freedom is made up of the 4 hospitals times 2 groups of people, that is males and females, times 10 people in each group minus 1. So the total degrees of freedom will be equal to 4 times 2 times 10 minus 1, or 79. The degrees of freedom within cells will be equal to the number of degrees of freedom within each hospital sex group times the number of hospitals and the number of sex groupings. So that will be equal to 10 minus 1, the degrees of freedom within each hospital by sex, times 2 sexes times 4 hospitals, or 72 degrees of freedom within cells. Now we will calculate the mean squares. First will be equal to sums of squares for hospitals divided by its degrees of freedom, and this value can be copied all the way down to sums of squares within cells. And just to make it a little neater, we'll change the number of decimal points to 2. Now there will be 3 f-tests, one for the hospitals, one for sex, and one for hospitals by sex, and each f-test will be conducted by taking the mean square for the appropriate category and dividing by the mean square within cells, and that will be fixed with an F4. And copying these down, we have these F values, and their probabilities are found with the F-dist. The value of the F, degrees of freedom in the numerator, and degrees of freedom in the denominator, and the degrees of freedom in the denominator will always be 72. And these are the probabilities. So it's possible to see that the probability for hospitals is less than 0.05. For sex, it's less than 0.05. For the interaction, it is not less than 0.05. The conclusion we would reach is that we will reject the null hypothesis of independence of length of stay and hospital. We'll reject the null hypothesis of independence of length of stay and sex, but we see no evidence that there is an interaction effect.